Hey guys, I'm back with another one. This time I've got a bit of a challenge for us. So, say for example, let's imagine that your parents pay you 100 Rand a week. The next week they pay you 110 Rand. The following week they pay you 110. The following week they pay you 120 Rand. And so forth. Every week they increase your allowance by 10 Rand. How much are you going to get paid on week 52? So we can simply go and say 120, 130, 140 until we reach, this is week 1, week 2, week 3, until we reach week 52, but that's going to take quite long. Is there a simpler way to do it? There always is. So that is going to introduce our topic today. I'm going to be doing a series of videos on sequences and series, and today we are going to be looking at the arithmetic sequence. Arithmetic sequences. So firstly, what are sequences? Sequences is a set of numbers that follows a specific rule. So sometimes the rules change. So for arithmetic sequences, we have what's called the common difference. Common difference. And it's denoted as D in our situation, in our case. And this is what defines arithmetic sequences. And an arithmetic sequence is a linear sequence with a common difference. So you get geometric sequences, you also get quadratic sequences, but right now we are going to be focusing on the arithmetic sequence. Alright, so how do we represent all of this? We said that it's a linear sequence that follows a specific pattern called the common difference. So how do we represent it? This is represented by the general term, which is called Tn, and it equals to the first term, which we're going to denote as T1, and we're going to add this multiplied by the common difference. So what is this part? So when we're referring to n, we are referring to the nth term in the sequence. So the nth term in the sequence is what this means. Tn is the nth term in the sequence. So, for example, if we want to find T100, we will just simply say T1 plus 100 minus 1 times D. Obviously, we have to figure out what T1 and D is, but that changes from sequence to sequence. Okay, so I think the best way for us to go further is by means of an example. Okay, so we've got an example here. It says the third term of an arithmetic sequence is 11 and the seventh term is 27. Find the first term and the common difference. Alright, so we have a sequence that looks like this: T2, T3, T4, T5, T6 and T7. It doesn't stop here, by the way. It doesn't necessarily stop at T7, it continues, but this is the information that we have. This is what the sequence looks like, and these are the terms. We are given that T3 is 11 and T7 is 27. So that is important information, and so is this. Oh, as well as this. This describes the type of sequence, and it gives us the necessary information. And they want us to determine T1 and n. Now if we go back to our general term, it says T1 plus n minus 1 times D. That is our general term, and they want us to figure out those two things. So how do we do this? Let's see. So we write down what we know. We know that 11 equals to T3, but T3 also equals to T1 plus 3, not n, sorry, 3 minus 1 times D. Okay, so we can say that 11 equals to T1 plus, I'm going to simplify this now already. 3 minus 1 is 2 times d. Okay, so this is the first piece of information that we have. Let's look at the other piece of information that we have. They say that 27 equals to t7. Sorry. Okay, and t7 also equals to t1 plus 7 minus 1d. And this equals to t1 plus 6d, and then we can say 27 equals to t1 plus 6d. Okay, so the next thing that we note is that we have two unknowns, t1 and d, t1 and d, and we have two equations. So the next natural thing to do is to solve them simultaneously. And because we have the same terms here and there's no difference in their coefficient, what I mean by that is that there's a 1 in front of t1 in this case, and there's a 1 in front of t1 in this case. So we subtract the two equations from each other to isolate the d term. What does that look like? Let's see. So we have that 11 equals to t1 plus 2d, and we have that 27 equals to t1 plus 60. Sorry, let me just make sure. Yes. Okay. This is equation 1 and this is equation 2. So what we are going to do is we're going to subtract equation 1 from equation 2. Right? We're going to take away 1 from 2, and we're going to do it on top of each other because that seems to be the simplest way to do so. So we write the 11 here, we write t1 there, and we write plus 6 equals, and we put a bracket down there. Oopsie, not 6. 2d, and put a bracket and a minus sign, and then we subtract them from each other. 27 minus 11 is 16. t1 minus t1 equals to 0. I'm not going to put that there. And then 6 minus 2 is 4d, right? So if we divide by 4 on both sides, we get that 4 is equal to d. Okay, so now we found d. How are we going to find t1? We find t1 by substituting d equals to 4 into either equations. I am going to choose equation 1 because it's the simpler of the two. And what I have then is 11 equals to t1 plus 2 times 4. I'm going to continue over here. 11 equals to t1 plus 8, and if we subtract 8 on both sides, we find that 3 is equal to t1. So we now found t1 and we found d. So what does our general what does our general term look like? Remember, our general term has this form. This is the form of our general term. So now if we fill in the t1 and the d that we got, we find that tn equals to 3 plus n minus 1 times 4. Alright, so let us check this. So we said that our general term now equals to 3 plus n minus 1 times 4. So and how do we check this? We make sure that the terms given are equal. So we go check what the t3 is. We do that by doing this. 3 plus 2 times 4, and that equals to 3 plus 8, which is 11. So this one is correct. Let's check for t7. That is 3 plus 7 minus 1 times 4. 3 plus 6 times 4, and that is 3 plus 24, which is 27, and this checks out as well. Alright, so this is the arithmetic sequences that we covered. Things to remember. What is important here is that we know that our general term looks like this. It's Tn equals to the first term plus n minus 1 times d. What is d? D is the common difference, and I need to add d can be positive and d can also be negative, which means that our sequences don't always go in the positive direction 1 2 3 4 5. It doesn't always go in that direction. It can also be 1 minus 3 minus 7 minus 11, etc. So it can also go in the negative direction, where we will find that our d in this case will be less than 0. That is something important that we should note and remember. Further to that, we need to remember what is also important is this part right here, checking that the information or that our general term is correct by applying it and making sure that our answers are the same. Also, we need to check d by making sure that we don't just, in this case we only had 2 values, but if we have more values in the sequence, we need to retest d. So we need to make sure that term 2 minus term 1 gives us the same d as term 4 minus term 3, for example. That is things that we need to check. Other than that, I will see you guys next time, where we will cover some more of sequences and series. Cheers.